Hello students, today I have the question number 16 to 22. There are the 7 questions and up to 15 I have told you. So now I start the Neet 2018 series AA. Question number 16 to 22. Now question 16. In a PN junction diode, the change in temperature due to heating number 1 options are does not affect resistance of PN junction diode, does not affect the resistance of PN junction. Second, affects only forward resistance. Affects only forward resistance. Affects only reverse resistance. Now third option is affects only reverse resistance, and fourth is affects overall VI characteristic curves, VI characteristics of PN junction. Now this we know that when the junction diode is heated, then the resistance increases, so resistance decreases, so the conductivity increases. So whether it is in forward bias or reverse bias, all resistances are affected. So it means that it affects overall VI characteristic of the junction diode. This is a direct question from the theoretical part. The change in temperature due to heating affects overall VI characteristics of junction diode. So this does not mean that will affect the forward bias or reverse bias, or it does not affect the resistance, but it affects overall. So our answer is, this is now fourth. And now question number 17. In combination of the following gates, in combination of following gates, the output by can be written in terms of input. In terms of input A and B as. So now let me take now first option is A dot B bar plus A dot B. Second is A dot B bar plus A bar dot B. And third is A dot B bar. A dot B bar. And now fourth is A plus B bar. And here the gates are given like this. This is your A, this is your B, A and B. And then this A, here we have this like this, and then this B and this A. So A we can write it like this. Here is this is in this way, and then this is Y. This is the given, these are the given gates. So here you can see that this is NOT gate, this is NOT gate. So this is A, NOT gate of B will give you the B bar. Then this will be multiplied to this one. This is AND gate, this is AND gate, this is OR gate. So what we have? This A. Now you see this one. First is this. Then A, and this is now B bar. A dot B bar. This is being multiplied. This is the AND gate. And then to this, that we have this A bar dot B. This is now this one, A bar. This is your B bar, and this is now your A, and this is your A bar into B, and then we add. This is now the output of these two gates will be the input of this OR gate, and then we will get it equal to 5. So what we have? Our right option is our answer goes to this second option. A dot B bar plus A bar dot B, or this A dash. This is A bar. So instead of this, you take this B bar, and this is A bar, B bar, this is A bar. This is so much. And remaining options are not correct because in the first you are given to this one, so A dot B bar, this is not given here. A dot B, this is not also given here. And this and the third A dot B bar, so this is NOR gate. No, sorry, NAND gate. This is NAND gate. This is NOR gate. So they are not the good options. This is also not the option. So right is second option. Now question number 18. An EM wave is propagating in a medium with a velocity v equal to vi, the instantaneous oscillator oscillating electric field of this EM wave, is along y-axis. Then the direction of oscillating magnetic field of the EM wave will be along Now options. First option is minus bidirection. Second option plus z direction. And now third option minus z direction. fourth, that is your minus x direction. Minus x direction. So now as you read the question, you will find that the EM wave is propagating along the x-axis. Velocity is given Vi. So I means this is along x-axis. And the electric field is along the y-axis, as this is given to this one. So solution is this is not so much. This is 0, this is x, this is y, and this is z. Then what we have? This is the this is what E vector, which is along y-axis. You are seeing the vibrations parallel to y-axis, and then parallel to z-axis, like this. So this is your V, vector V, that is along z-axis. This is now V. Wave is traveling in this direction. This is V equal to Vi. So definitely you can have that the direction of E is towards Y and direction of B is towards Z. So to find the direction of this wave, that we can have this, we have to find this Z direction of B. So all these vectors are mutually perpendicular. So this is your I, this is your J, this is now K. Then to find the direction of this one or this one or this one, that you can see that this is along Y. So this is your J cross. Now this is your K. Then this is equal to I. J cross K equal to I. So I is given here. Then this is your like this. Then this is in this way. So you are getting this the speed of the EM wave. So our right option is that B must be along Z axis. B along plus Z axis. This is, so our option is, what should be our answer? Plus Z axis. It means the second one. Then the question number 19. The refractive index of the material. The refractive index of the material of a prism is root 2 and angle of prism is 30. Is root 2 and angle of prism is 30 degree. One of the two refracting surfaces, one of the two refracting surfaces of the prism is made prism is made of a mirror inward, of a mirror inward by silver coating, by silver coating. A beam of monochromatic light, a beam of monochromatic light enters the prism, from the other surface, from the other surface, will retrace its path, will retrace its path after reflection from the silver surface, after reflection from silver surface. If its angle of incidence, on the prism is, now your options are, first option is 30 degree, second option is 45 degree, and third option is 60 degree, and the fourth option is 0. Now the solution. First we have to read the language of the question very carefully, and then we can find the solution of this one. You are given the prism of refractive index square root of 2. Prism angle is given to be 30. Now you can see that that refractive index, this is given to be root 2. Prism angle is so much. Now what the strategy made in this question is that one of the refractive surface is polished by silver, so that a mirror is made inward. Now here you are given that mu equal to root 2, a equal to 30 degree, and then what is given, that a monochromatic light ray enters the prism from the other side, will retrace means that the after reflection it will follow the initial path. Reflection from the, this is given, the reflection from the silver surface. If its angle of incidence is, अगर इतना एंगल ऑफ इंसिडेंस होगा तो ही ये रिट्रेस करेगी, नहीं तो नहीं करेगी. So this is the prism now Now this angle of the prism is given to be 30 degree. This is known to us, given in the question. And this surface is made, suppose, silver, like this. This is the mirror. This is the silver mirror. Silver mirror. You would have studied about the reflection from the mirrors, that when the light ray goes parallel to the principal axis, or this is along the principal axis, then this is reflected as such. So it does not have any kind of deviation. Suppose this is the monochromatic light. It means that what the light goes here, that must be the principal axis of this mirror. Principal axis of this mirror. And principal axis, we know this is always perpendicular to the surface of the mirror. So this will be like this one. And it means that this refractive surface A, B, C, the refractive surface AB, that this must be the normal of this surface AB. So we have this normal. This is the normal. Normal what's into the principal axis. Then this will retrace from here and goes back. Suppose we have the normal at this point. This is also normal to this surface AB. Then this is the angle of incidence that we have to find. That what must be the angle of incidence? The ray. Entering the prism will retrace after reflection from silver surface AC if it is incident normally. It means that if this falls normally on this surface, then this angle must be equal to your 90 degree. This angle is 90 degree. Then what we have? That this angle is 90 degree, then definitely this angle is 60 degree. So if we take the name to this one, this suppose your P, this is now your Q, and then we will have this AQP, angle AQP equal to 90 degree. Then angle to this, then angle APQ. This is now your 180 minus 120. So this is now 60 degree. When this is 60 degree, then this is the angle of refraction. This is the angle of refraction. Angle of refraction. So angle of refraction. Angle of refraction. This R is equal to this total angle is, because this is the normal, so this will make an angle of 90 degree. So 90 to this one, we will subtract this angle, that we have found it to be 60 degree. So this is your 90 degree minus 60 degree. That is equal to now 30 degree. And now we will apply Snell's law. Snell's law. What we have, this mu equal to sin I upon sin R. You have to find the I. Sin I equal to mu sin R, and this is your sin I is equal to mu is equal to root 2. Sin R is to 30 degree. This is now 30 degree. So sin I equal to root 2 into sin 30 1 by 2. So this is equal to root 2. So it gives you this I equal to 45 degree. 1 upon root 2. This means that this angle of incidence must be 45 degree. Only then the light ray entering this prism will retrace its path after reflection. So this we have to keep in mind, that the light ray moving along the principal axis of the prism of the mirror always reflects as it is with no deviation, and then this is we know that the principal axis is always at the right angle to the mirror. So this is now angle now 90 degree, then this is now given 30, so this will be now 60. This whole angle is 60 degree, so in 90 degree, then 90 minus 60, this is now 30 degree. So angle of refraction is 30 degree. Now apply the Snell's law. So that will give you the answer. That the angle of incidence must be 45 degree. Our option right is the second one. Option second. So this is the question number 19. And now I take question number 20. Now 20 is what? An object is placed at distance of 40 centimeter at distance of 40 centimeter from a concave mirror, from a concave mirror of focal length 15 centimeter of focal length of 15 centimeter. If the object is displaced, now I have this attached to this one. So what we are given, if the object is displaced centimeter towards the mirror, towards the mirror. The displacement of the image will be. Now your option. Your first option is 30 centimeter towards mirror. Towards mirror. 36 centimeter away from mirror. 36 centimeter away from mirror. And now third option, 30 centimeter away from mirror. 30 centimeter away from mirror. And fourth is 36 centimeter towards mirror. 36 centimeter towards mirror. These are the options. You are given the concave mirror. Concave mirror. This is given you the concave mirror. This is the focal length f, and this is now your 15 centimeter. And object is placed at 40 centimeter. Suppose this is your object O. This is now your 40 centimeter. So for the first time we find the position of the image. This f is equal to minus 15 centimeter, u equal to minus 40 centimeter, all negative. 1 upon v plus 1 upon u equal to 1 upon f. Then this 1 upon b we have to find, minus 1 upon u. This is now your 40 minus 1 upon 15. So from here we will have this 1 upon b equal to, this is now plus 1 upon 40 minus 1 upon 15. So you can have the LCM. This is now 120. So this will be your 3 minus 15 8 so much. So this is minus 5 upon 120. 5 2 and 5 4. So we have this b equal to 24 centimeter. Again we are given this b equal to minus 20 centimeter. What happens that the object is displaced towards the mirror. So this is now at 20 centimeters. This is now 15, then this is 20. So this is now O dash. So this is now new position, B dash. So this is now 20 centimeters. So much is 20 centimeters. This is given to you. Then again we have to this 1 upon B dash plus 1 upon U equal to 1 upon F. Now 1 upon B dash we have to find, minus 1 upon U, this is your 20 minus 1 upon 15. So 1 upon B dash equal to 1 upon 20 minus 1 upon 15. Now you can have the LCM. This is now 60. So this is now 3 minus 4, or V dash equal to your 60 centimeters. It means that initially it was at 24 centimeter, then at 60 centimeter. Here we have with a minus sign. So when it was at this point, then it has gone to this one. So there will be, the image will shift away from the mirror. So now we find the shift, we should just subtract. Shift of image equal to V dash minus B. V dash equal to minus 60 minus, so this is now plus 24, so this is your minus 36 centimeters. So this will be away from the mirror, away from mirror. Away from mirror. So our right option is to what? 30 centimeter, 36 centimeter away from mirror. So right choice is now your second one. This is our correct answer. Now question number 21. 21. The magnetic potential energy magnetic potential energy is stored in certain inductor is stored certain inductor is millijoule. The current in inductor is inductor is 60 milliampere. The inductor is of inductance. The inductor is of inductance. First is, your options are 1.389 Henry. Second, 138.88 Henry. Third is 0.138 Henry. And fourth is 13.89 Henry. This is given to you. You are given the magnetic potential energy, magnetic potential energy. This U equal to half L I square. This is the formula. You are given U that is given to 25 millijoule. So 25 into 10 to the power minus 3 joule. I is given to you 60 milliampere. So 60 into 10 raised to the power minus 3 ampere. You have to find the L. L you have to find. So this L equal to 2U upon I square. This you can write. So this 2. U is 25 into 10 raised to the power minus 3. I is 60. So multiply 2 times. 60 into 10 raised to the power minus 3 into 10 raised to the power minus 3. 2 times. So 1 will cancel from here. And you can have this 2 to this now you have 30. 5 to 6. 5 to this now 5. And 5 to this 12. So 72. 10 raised to the power minus 3 will go up. So this will be 1000 upon 72. 1000 from here. Minus 3 will go in the numerator. That will be 1000. And 6 into 12. 6 into 12 equal to 72. So this is 72. So one time that this will go here. And you will find it to be your 13.89H. 13.89H. This is now fourth one. So right option is fourth. And now the last question, today's last question is 22. An electron falls from rest. An electron falls from rest through a vertical distance vertical distance h in a uniform and vertically upward directed electric field E. The direction of electric field is now reversed. The direction of electric field is reversed. Is now reversed, keeping its magnitude thus, keeping its magnitude the same. A proton is allowed to fall a proton is allowed to fall from rest in it through same vertical distance h. The time taken of fall of the electron, of fall of electron in comparison to the time of fall of proton is number 1 10 times greater. Second, 5 times greater. Third, smaller. And fourth, equal. These are the options. Solution is what? The electron is falling freely through the vertical distance h in a uniform and vertically upward electric field. तो हम यहाँ पर एक इलेक्ट्रिक फील्ड लगे. This is the electric field E. ये इलेक्ट्रॉन है. This electron is here. Electron. It falls from rest, so initial velocity is equal to 0, and it falls to the height, vertical distance like this. This is not suppose vertical distance h. This is now h. So definitely it have this height h. Uniform electric field is so much. Electric field is so much. Then there will be the acceleration, and this electron being the negative charge, this will acted upon in the reverse direction. So electric force on electron F equal to E into E. So the acceleration A equal to E into E upon ME. ME the mass of electron. ME mass of electron. Then this vertical height. Vertical distance. This will use the formula y equal to ut plus half a t square. the second equation of motion. Second equation of motion. So y is given to be now h, u is equal to 0 plus half, a is given to be e into e upon me into t. This is now your t square. We are taking 4 electrons, so we will take this t equal to te. And we will get this t equal to 2h me upon e into e. This is now square root. So much. This is for electron. Then what is given? The direction of electric field is reversed. First is vertically upward, then this is now vertically downward. So now this second situation. This is now electric field E. This is now proton. It falls from the rest to the same height. This is now same height h. So again the acceleration of proton A equal to E upon mp. Mp the mass of proton. Mp mass of proton. And now again using the formula vertical height distance, using the formula y equal to ut plus half a t square, as I have used here. So here this y is equal to your h, this is 0, this is now your half, a is equal to e upon mp into t dash square. This we take now, suppose t dash, or t dash equal to 2h mp upon e. This is now square root of so much. Then what is being asked in the question? The time taken of fall of the electron in comparison to the time of fall of the proton. So you have to find the t upon t dash. So t upon t dash. T is here, this is square root of 2h me upon e into e into, this is now your square root to h mp e into e. So this will cancel to all these terms. Then we are having this square root of me upon mh. So this is t upon ts. This is the time taken by the electron, this is the time taken by the proton, and this is the mass of the electron, this is the mass of the proton. It means that this t is directly proportional to the mass, or time is proportional to square root of mass. So you can see, since this me is less than mp, therefore t dash is less, T is less than T dash. So now time will be smaller. This is never equal. T and T dash are never equal, and you can find that the time of the electron is never more than the time of 4 of this proton to the same height. So our answer is your third. This is the third answer, small. So this is the question number 22 of this series. So you watch the video completely. Thank you very much.